Hello viewers, I am Kausalya. Today we are going to discuss about problems on series parallel circuits. So what do you mean by series parallel circuits? Here in the upcoming problem we will be having circuit as a combination of series and parallel elements, right? That is, we will be having both series and parallel elements in the same circuit. So here, let's start with the first problem. Find the voltages across R1 and R2. Also find the value of R3. Right, this is our given circuit diagram. So in this circuit diagram, we have to calculate the voltage across R1, R2 and we have to find the value of R3. Right. So what are all the given data? So from the circuit diagram, we are having a voltage source of 100 volt. The value of resistors are 10, 20 and 80. We don't know the value of R3. We need to calculate. And the current flowing through this 80 ohms is 0.5 amps. Right. So now we have to calculate the rest of the things. So the first thing is, you see, we know the value of current, we know the value of resistor. So we can calculate the voltage across this 80 ohm resistor, right? So V is given by I into R. So this is the value of I and this is the value of R. That is 0.5 into 80, right? So that is our first step. Voltage drop across 80 ohm resistor is 40 volt. That is I into R. And the next thing is, you see, this 80 ohm resistor and this R3 resistor are connected. How they are connected? Parallelly or in series? So these two resistors are connected parallelly. So what is the law of parallel connection here? That is, the voltage impressed across the resistors will be the same. That is, here the voltage across this 80 ohm resistor is 40 volt. The same 40 volt is impressed across this R3 resistor also. Right. So voltage across R3 resistor is equal to 40 volt again. Right. So in order to get a clear idea, we are just redrawing the circuit. Right. So here again these two resistors are drawn like this. Again both the circuit diagram have the same meaning. Right. That is, you see, here the two resistors in parallel are connected or drawn like this. The same way we are shifting these two resistors here. Okay, all the connections holds the same. So here we have just redrawn the circuit diagram. Right. So in this case, the voltage across this resistor, these two resistors are found to be 40 volt. Right. So here the total supply voltage is 100 volt. If 40 volt goes here, what about the remaining voltage? The remaining will be 100 minus 40, that is equal to 60, and that 60 volt exists across these two resistors. Right. So that is our next step here. Then as usual, we know the value of resistors, we know the voltage across them. So we can easily calculate the current flowing through them, right? So again by Ohm's law, V is equal to I into R. So here the value of V is 60 and I is the current and the value of resistance will be 10 plus 20, right? Because they are connected in series. So the total value will be 30 ohm. Now what about the value of current here? So the value of current here is 60 by 30, which is nothing but 2 amps here. Right. Now we know the value of current. Right. We know the value of resistors. Now we can calculate the voltage across 10 ohm resistor and voltage across this 20 ohm resistor. Right. So here voltage across R1, it is given by I into R. So here I is 2 and the R is 20 volt. And similarly voltage drop across R2. The value of resistance R2 is 20 ohms. So here the current flowing through this is 2. Therefore the voltage is 40 volt. Right. Now the next thing is, we need to calculate the value of this unknown resistance R3. Okay, we had calculated the value of phi, that is I here is 2 amps. right? We had just now calculated. And so here it is 0.5 amps. Then what about the current that flows through this path? 2 minus 0.5, that is 1.5 amps flows through this resistor. Can you get? Here even you can consider Kirchhoff's current law. That is, the current flowing, the sum of current flowing towards the junction is equal to sum of currents flowing away from the junction, right? Therefore, the current flowing through this R3 resistance is 1.5 amps. Then what about the voltage across this R3 resistance? It is already calculated as 40 volt, right? Therefore, here we know the voltage, we know the value of current. Therefore, we can easily calculate the value of resistance again by using the Ohm's law. So, this is what done here. Voltage drop across R3 is 40 volt, right? Therefore, the voltage drop is I3 R3 is equal to 40. So, R3 is nothing but 40 by I. What is the value of current that flows through the R3 resistor? It is 2 minus 0.5, which is nothing but 1.5. Therefore, the value of R3 is 26.7 ohms here. Right. So, finally, we had calculated the voltage across resistors R1 and R2 and the value of unknown resistance R3. Right. Now the second problem is find V in the circuit. So this is the given circuit diagram and we are asked to calculate the value of V here. Right. So now the first thing is just look at the diagram and tell, is there any resistors which are connected in series? So before to proceed with, I'll tell you, you need to calculate the voltage here, right? So when you apply Kirchhoff's voltage law, what is Kirchhoff's voltage law? Sum of potential rise is equal to sum of potential drop, right? So here this is the only potential rise. So the rest all are potential drops, right? So here the thing is, when you simplify the circuit, right, and when you calculate the voltage drop across the resistors, then when you add the summation of voltage drops, then by KVL you can get what is the value of V, right? Let me explain step by step. So here the thing is, you have to reduce this circuit diagram, right? So when you observe carefully, you see this 20 ohm resistor and 50 ohm resistor are connected in series, right? If you have any doubt, again, only in series circuit the same current flows, right? So here you see, to this 50 ohm we are having 2 amps, right? In the same way, here also the current flowing through this 20 ohm resistor will be also equal to 2 amps, because you see there is no division of current takes place. The same current flows down here, right? Or in other words, again the ending point of one resistor becomes the starting point of the other resistor. So here in this case, you see, for this 20 ohm resistor, this is your starting point and this is your ending point. But for a 50 ohm resistor, this is that is the ending point of 20 ohm becomes the starting point of 50 ohm. Right. Can you get what I am saying? So the thing is, these two resistors are connected in series. So how to calculate the equivalent resistance? Simply we have to add the values here. That is 20 plus 50 will give you an answer of 70 ohms. Right. So this is what I had written here. The next thing is, so just I had redrawn the circuit. Right. Here a current of 2 amps flows and these two are in series. So I had just added them. So here the resistance is 70 ohm, right? And the current flowing through this 70 ohm resistor is 2 ohms, right? Then here what about the voltage drop across this 70 ohm resistor? Can you guess? So here the voltage drop across this 70 ohm resistor is equal to, by Ohm's law, I into R. So this is your I and this is your R. Therefore, the voltage drop across this element is 140 volt here. Right. So now again consider these two resistors, 100 ohm and 70 ohm. Now can you just tell me how they are connected? Either they are connected in parallel or in series form. So here again, to know this, you see, at this point the current splits, right? The current gets divided. You see, there is some amount of current which is flowing through this 50 ohm. When it reaches this point, the current gets divided. Whenever the current gets divided, the two elements are said to be in parallel, right? Or in other words, you see, that is one end of 100 ohm resistor and one end of 70 ohm resistor are connected together, connected to a common point. Similarly, the other end of 100 ohm resistor and the other end of the 70 ohm resistor are connected to a common point, right? So 100 ohm and 70 ohm resistors are connected in parallel. So in order to get a clear view, again I had redrawn the circuit, right? So these two resistors are in parallel, right? This diagram and this diagram means the same, okay? It doesn't make any difference. If you have any doubt, even just you can keep this nodes as A and B and check, right? To this node A, one end of 100 ohm and one end of 70 ohm is connected, right? So again here consider this as node A and this point as node B. So to this A, one end of 100 ohm and one end of 70 ohm is connected, and again at node B, other end of 100 ohm and other end of 70 ohm is connected. So other end of 100 and other end of 70 got connected, right? So these two circuits have the same meaning, right? Now the thing is, you see, across 70 ohm, here we are having a voltage drop of 140 volt. So the same 140 volt is impressed across this 100 ohm resistor also, right? So we know the value of R, we know the value of V. So we can easily calculate the value of I, right? So here the voltage across 100 ohm resistor is 140 volt, and here again I into 100 is 140. Therefore the current flowing through this 100 ohm resistor is calculated as 1.4 amps, right? Now the next thing is, we are going to calculate the current flowing through this 50 ohm resistor. How to calculate the current flowing through this 50 ohm? The thing is, you see, again the current coming, that is the current flowing through this path, gets divided into two like this, right? So here, what about the total current here? That is 1.4 plus 2 amps is the total current that flows through this 50 ohm resistor, right? So the current flowing through this 50 ohm resistor is 1.4 plus 2, because that is the current which gets splitted into 1.4 and 2. Right, so this is the total current is 3.4 amps here. Right, again KCL, sum of current flowing towards the junction is equal to sum of current flowing away from the junction. Right, now you see, we know the current flowing through this 50 ohm resistor, therefore we can calculate the voltage drop across this 50 ohm resistor. So the voltage drop is calculated as 170 volt here, right? So the thing is, again I am simplifying this circuit to make our concept more precise, right? Here the two resistors are connected in parallel. So how to calculate the value of total resistance? So here it is calculated by R1 into R2 divided by R1 plus R2. Therefore the value of this resistance is 41.2 ohms. Right. So again when you redraw the circuit, the two resistors are replaced by this 41.2 ohm. Right. Now this is our final simplified circuit, and we need to calculate the value of voltage V here. Right. So the voltage drop across this 50 ohm resistor is 170, and voltage drop across this 41.2 ohm resistor is 140. Right. So by KVL, voltage drop is equal to voltage rise here. Right. So V is equal to, that is voltage, we need to calculate V. This V is nothing but summation of these two values. So 170 plus 140, that finally gives the value of V as 310 volt. Right. Again, this is a basic concept. Repeatedly, we will be using Kirchhoff's current law and voltage law in most of our problem solving methods, right?